This is the presentation of the master's degree in engineering physics. My name is Jordi Martí. I am the coordinator of the studies. And our motto, as you can see here, is Physics for Engineering in the 21st Century. So this means that we are interested in offering brand new studies in the edge, let's say, of the physics and the engineering sides, in order to students get able to develop and create new devices or new technologies. These studies have been developed in the Department of Physics of the UPC, and the management is done by the Barcelona School of Telecommunications. So essentially my talk will have several parts. First of all, the motivation. We want to explain essentially what means engineering physics, because it's a concept quite new. Then we will show some references of different places in the world that they are delivering similar kinds of studies. Then I will talk about the objectives of the master, academic organization, our program, our two-semester program, the schedule for these next 2 semesters, and finally I will summarize just showing the most important details. Okay, the motivation. What means engineering physics? Why is it interesting that you enroll and you do these studies? Here there are several interesting examples. For instance, quantum computation. Quantum computation is something that is being developed in these times. Many people is working on the quantum computers, the next generation of computational devices. But quantum means that you need to use and know very well about quantum mechanics. So this is something where engineering and physics go together. Or nanotechnology. Nanotechnology based on, in many times, in very tiny devices that you can insert in a different kind of machines. For instance, here in the figure you have a graphene sheet. Graphene is an amazing material that you can model in several ways. It has interesting mechanical properties, also electric properties. It can work as a semiconductor, as a transistor, so it can have an important role in the industry of computation as well. For instance, here I am showing a chip made of carbon nanotubes that has been developed in the MIT recently. And again, is another matter in where physics and engineering converge. Or optical chips connected with quantum computation. These are all also matters that are in the edge of the research. Or micro devices. Here I am showing an image of the so-called chip in a cell. So something people is trying to reduce even more the size of the chips in order to get better performance and smaller size. And finally, the energy sources are, of course, very important. Here is an image of the ITER fusion reactor, which is being built in France these days. And in our case, again, the learning of physics and the contact with engineering is essential for this kind of studies. Okay, the motivation from another point of view is in UPC we had from about 8 years ago we started the baccalaureate in engineering physics. This has been a very successful kind of studies. Every year we have about 30-35 graduates. They are very high level students. They finish with the students with a high level of abilities. Just mention that when they just in the starting point of the studies, they have to pass a selection, and the minimum mark entering the studies is about 13/14. So these are absolutely brilliant people who enter the studies. So our call for this master is essentially to these people, and of course other people from outside, but to fill a gap that was in the UPC. We had the baccalaureate, we have several PhD programs, which I am showing here, but we didn't have the master, and finally this year it was possible to open it. It started in September this year with the first semester, And we have at this moment 12 students. We expect that this will increase in the future. And the master is a very good opportunity if you are interested in continuing your studies and doing a PhD program or PhD studies. After our master, the most natural way is to continue in the computational applied physics program, which is particular of the UPC. And also there are other programs to continue, like the nuclear and ionizing radiation engineering, or other programs not so linked to the master, which are applied mathematics, photonics, etc. So I just mentioning the most relevant ones. It's possible, of course, and it's something will happen, hopefully, in the next future, that people with the master, they will work at the industry or in laboratories around. They can, of course, do some mobility outside with this title. And here I am showing several important industries that are in contact with the School of Telecommunications. Here we have the web page, hopefully will show up. And we will see that in the School of Communications in Barcelona, let's see, okay, here it is. There are about 280 industries or enterprises that are in close contact, and they are open an opportunity for the master students to get some opportunity at these enterprises. So this is something that we have to take into account. Well, for some reason it has closed. Let me open again. Probably opening the... Okay. This was right here, sorry. Okay, here you were. I probably will prevent to open other web pages because it's going to close the PowerPoint presentation. So just let me mention that we have contact with the Alba Synchrotron here in the close to Barcelona, also with the Hospital de Cheus, very close as well, or the Radiofísica Hospitalaria, which is a group of Spanish labs, and also with the Barcelona Supercomputing Center, which is very close to UPC. So in principle, the contact of the students with industries and laboratories is very, very easy and very often to happen. Our staff from the physics department and engineering departments of UPC, they are collaborating in the master, of course. They are the teachers, and they are in general very active in research. Most of them are offering PhD positions in their research groups. So again, the link between the studies and the continuation, the natural continuation, is very already included in the staff. What are the references for these studies in Spain, in Europe, and in the world? In Spain, there is only another master of the same class being teaching the Basque Country, as we see in number 6. In Europe, we have several of them, in Italy, Sweden, Finland, and I know that without the same name, with a similar name like Applied Physics or Applied Engineering or something like that, there are masters very similar in contents in Denmark, France, Germany. Normally in Northern Europe, they are very sensitive to these kinds of studies. And outside, here we are mentioning 2 of them in Cornell University or in Quebec. So the message is the Master in Engineering Physics is being increasingly offered throughout the world, and for that reason we are happy to be able to offer here in Barcelona. The objectives. First of all, these are brand new studies, as I have mentioned before. Of course, it's the combination of physics at the advanced level and cutting-edge engineering. The connection with the active research groups and the UPC, it was mentioned a moment ago. And the topics corresponding to the active research groups are nanomaterials, quantum optics, instrumentation, etc. So most of them are deeply related with the examples I have shown at the beginning. For instance, here, let me try, if this works, is a simulation of a protein close to a cell membrane. So this is something we are doing in our research groups. And it has to be considered as one of the possible projects linked to this master. The objectives, of course, is to connect the master with the telecommunications school network, and for most of the students, or part of the students, to have contact with the private and public sector, and hopefully to get a job there. And here I am also reporting the two most important webs related to this master. The first one is the web I have to open, hopefully it will work. This one is our web, where we include all the information related to the master. Here you can go and check a lot of data, and especially I want to mention the pre-enrollment link, which is here, that has to see that we are opening enrollment for the second semester. This is a new feature that some masters are not doing, but we are doing it. And this is an opportunity for students that want to start with some elective courses, which I will explain in a moment. And if you are interested, you can go there and go on and pre-enroll. The second web page we should check is the page of the, well, I cannot scroll down, but of the telecommunications school concerning to the master, where you see additional data like the prices, like the possible organization or possible outputs, etc. Okay, this is the information, so please have a look. And let me go back to the presentation. Now it works. The academic organization, as I mentioned before, the managing is the administrative managing is doing by the Barcelona School of Telecommunications here at B3. I am the academic coordinator of the master, and we have an advisory committee formed by relevant professors, which are helping us in the contacts with international universities and labs, or with industries, etc. The classrooms are located in North Campus UPC. The labs, most of them are in the same campus and in other UPC campus. And as I mentioned before, the students have the chance to work at the Alba Synchrotron, which is about 25 kilometers away, and also in labs at the Terrassa campus, which is a city located about 30 kilometers away from Barcelona, but in any case, these are close locations. The master thesis normally will be done in a research group of UPC, but can be normally done as well in foreign institutions or companies, with the only restriction that one of the supervisors has to be a part of the staff of the academic master. Okay, the program. Let me focus on the program. The master includes 60 credits. In the UPC, the credit is corresponding roughly to 25 hours of personal work, including classes and homework. And we are, the master divided in 2 semesters, which include 3 kinds of topics. First, a group of compulsory courses topics, which correspond to 23 credits, so a little bit less than half of the credits. Another bunch of 20 credits of elective courses, so the election is really quite wide in this master. And finally, the master thesis covers the remaining 17 credits. The compulsory courses include 5 subjects. First of all, the one about critical phenomena and complexity. It has to see with phase diagrams of statistical systems, renormalization group, studies about networks, scale-free networks, etc. This is essentially basic physics and advanced physics, but continuing a normal bachelor. The second topic is also very important, is quantum matter. It has to see with extension of the already studied quantum mechanics. And they explain about the perturbation theories, variational methods, scattering, second quantization, etc. So these are, of course, for most of the applications which are in the edge of the science today, these are basic topics. Then we have two oriented to experimental work, which are surface engineering and micro devices, which is sharing the classes in the North Campus in UPC and in Terrassa. Then we have large facilities involved with the synchrotron, and where the students will practice with the synchrotron and with neutron sources. So these are important experimental techniques that should be mastered. And finally, we have a different topic called project management, which has less credits, but is very important because includes the analysis of a project, the study of the needs of a given project from the human and material sides, the evaluation of risk, and eventually the preparation of contingent plans, the evaluation of the quality of the results. So all this information is very important to be able in the future for the students to manage different kinds of projects. About the elective courses, here I am listing all of them. The first three are given already now in the first semester. One of them is Physics of Materials, so linked to the nanotechnology. Then we have two computational-like topics, one about machine learning and neural networks, which is a very wide and useful tool. Then we have numerical methods for continuum systems, related essentially to fluid dynamics. In the second semester, so starting February, students can choose between computational astrophysics, so computational tools to analyze stars, galaxies, etc. Then another topic about atomic and molecular physics, so also related to experiment and computation, of course, at the atomic level. Then a topic on complexity in biological systems, so more related to the study of proteins, membranes, etc. Another topic about soft condensed matter, so quite linked with the previous one. Soft condensed matter includes a variety of topics like polymers, like colloids, membranes as well, micelles, etc. And finally, another topic about the stochastic methods, so using random tools for optimization and simulation. This is maybe a topic in between of theory and experiment. The elective courses can be taken, some of them from different masters, not only from our own offer. And the maximum allowed is 12 credits. And here I am just listing the most relevant ones or the closest ones to our master. And as you see, you can choose between courses related to nuclear engineering and energy technologies, or related to optics and computer vision, so related to other masters offered by UPC, also related to data mining and to biomaterials. So the variety is quite wide and is a good complement for the other elective courses we are offering. About the master thesis, I want to remark that, of course, has to be supervised at least for one of the professors of the master, but can be done either here, either in other centers at the UPC or outside or abroad. And our management will help the School of Telecommunications and myself to the students to find out a good option for the master thesis. And of course, we will offer a list of different works to choose for the students. This is in preparation. About the schedule, as I have highlighted before, we are starting normally in September, in this case September 2020, but in this year we are opening again the enrollment in February 2020, if there is somebody interested in starting first with eligible courses. And this means that optimally you should start in fall semester and continue in the spring semester, but you can start reverse way, starting in the spring semester, doing first, let's say, considering first elective courses and led the compulsory courses for the September semester. In any case, the master thesis can be only enrolled after all the compulsory subjects have been passed. This is a requirement that we think makes sense, and it has to be done this way. Well, this is a summary, so I have no more to say right now. Just again, show you the compulsory and elective courses we are offering, and just send you the message that these are brand new studies, so we are offering something which is quite new in the area, and we encourage you to enroll and do a good master thesis. So if you have any question, please feel free. Here I am.
It's just to point out that those of you that are interested to start in September 2020, please don't do the pre-enrollment now. Wait until 1st of March, that then it will be open until July. But for those of you interested to start in February, yes, you have to do it now. But for those of you that not, please wait until March, just to point out this. Thank you.
Okay, so there are no questions, so let's close the session here, and well, feel free to send emails or to visit us and ask everything you need.